Yeah, actual. You can say physical, real, actual. Real's fine. Whatever you want to use. But
When you say you usually give us an LED, make sure we did it right.
well, I think what we'll do is we'll use LEDs next week
Okay.
or Thursday. I'm sorry, we meet on Thursday, so we'll use LEDs then. Oh my! Hey, I'm over here. It loses me if you go too fast.
Do you round up or do you want the 97.8?
Round up or down depending on the 0.5. So take it to 2 decimals, and that'll solve all of it. Okay. Oh, I'm good to 2 decimals. You can get to 2 decimals, you'll be within anything out in the field that you'll do.
So is this what you're looking for, Gordon? This is what I had actual.
Yep, that'll work. Make sure you put ohms there.
I did. I thought I did.
Okay. And now show me the calculations. So you're actually gonna do the calculations, and then you're gonna go ahead and measure it and see if they add up to it. I want you to.
Calculations.
Okay, so now you can add these up.
Right.
Show me an equivalent circuit.
Okay, you want
So yeah, this
R total.
yeah equals R1 plus R2 plus R3. Okay, and then show me that equivalent, and then calculate your current. Yes, sir.
So this shouldn't go more than 198. 199.
Okay.
So I mean, you're really close, but
It's close enough. Okay. Those resistors are carbon. Oh, that's a silver band, you know.
brown.
That's a silver band, so it's 10%. It's 10%. Does that help?
Yeah. No, it doesn't change anything.
Were you 5%?
No, I was on 10%.
Okay, you're on 10%. Close enough.
How many decimal points do you want to go out on the amps?
2.
2.
Don't go more than 2, guys. You're never going to go more than 2 out in the field unless you're working on a.
I'm assuming this is what you're looking for.
If you have to turn in multiple sheets, that's fine. Yeah, and then show an equivalent circuit. Okay, with a battery and one resistor that's RT. Okay. Oh, and when you turn in your notebook paper, tear off that little thing on the side. It's made so you can tear it off. It's really frustrating. Only 4 people, it's not a big deal, but you get 20 people, you got all those little things that are all fluttered on the end. It's a mess. So just tear them off. That's why they perforate it now. It's pretty cool. I don't know if you know it, but they use an arc to do that too. It's little points, and they just fire it across, and it puts a hole in the paper.
You want these off?
Yeah. Just tear them off. There should be. Your paper perforated? Or, yeah, it is. See, you can just twist it here.
Oh, it is. Okay.
See? And you just tear that off. It makes it really nice. If you fold it, it just tears right off.
So do you want these?
You got to do a parallel now. Did you get all of that? Did you make your measurements? Was your meter?
As far as.
You're going to do voltage, voltage, voltage. So measure a voltage across each one of them.
You have to break that circuit?
No,
to do
that's
that?
for current only. When you do the current, you have to break the circuit. When you do the voltage, you just measure right across them. Okay?
Right across the resistors?
Right across each of the resistors, and it should come out pretty close to what you calculated for each one of them. Okay? What'd you calculate for that resistor?
Why is this staying on?
Oh, are you on
Oh, I'm way over there.
there? How about that? Okay? Because there is a little voltage in the air. And then you. There you go. Okay? So now, when you calculated the voltage for each of these, because you got the current here, right?
Mm-hmm.
When you got that current, then you could put it in here, okay? And then you could calculate the voltage for each one of these, all right?
Mhm.
And when you calculate the voltage for here and then you measure it, they should be really close. So you have to do that calculation. You have to show it to me. Okay? How are we doing, Casey? Yeah, that looks good. Okay, I don't see your equivalent circuit here. When you added them all up, where did you put that?
Oh,
When you added all your resistors up? I know you did it in your head.
right here.
Okay, right here? Okay, then you should have showed me a little equivalent circuit, like I did on the board. Remember?
Oh, okay.
Always show me, always show me that equivalent circuit. Right now it's not a big deal, but when you get the complex circuits, it's going to be really important that I see each of the equivalent circuits. And if you made a mistake, I can tell where you made the mistake. That way I don't have to just say, gee, it's not there.
Okay.
See? So what you're going to do is you're going to show me 9 volts and a single resistor of the total resistance.
Okay, for one for each.
Well, you added these up to get RT, right?
Yeah.
Right there.
Yeah.
So you can just even show it right here in the corner. But just show it to me.
Like that.
Yep. Okay. Now, here's what we're going to do. You can decide which one it's going to be, but I want you to take and build this combination circuit. And then go ahead and build it after you do the calculations. You decide. If you want to use R3, that's fine. You can use R1 or R2, whatever combination. You just build it and show it to me, and then I'll calculate it and grade it. Okay, cool. So you got yeah, you're doing the current. Well, okay, so you got to put a designator on these. Are they voltage? Are those voltages?
This is actual voltage.
Okay, so it's V. So what's this letter here?
This is
a voltage, right? This is an I. This is Z, right? Voltage, right? So you don't want to have an I there, and you don't want to have an A there.
I had something going on now. I'm lost.
Okay, so erase those. Okay, erase that one.
That's actual.
Oh, actual, okay.
Ideal,
Okay.
actual.
So you might not want to use A because it looks like amperage. I already know that this is actual down here. Just write right here, actual. There. Now everything below this I know is actual. Okay? Otherwise you're going to get yourself confused. Okay, so now you have voltages for each one of them?
Mm-hmm.
Measure them and see if that's correct. Are those the calculated voltages or the measured voltages?
These are the actual. This is calculated. This is
Okay.
actual.
But you don't have a calculated one here or
I
here.
haven't got that for you.
Oh, okay. I'll get
I
out of
just
your
calculated.
I'll get out of your hair. Put a 0 in front of that 0.01. Anytime you write current, put a 0 in front of it, okay? Just helps people to understand what it is. You doing okay? Yeah.
So I measured the battery first, I got that, but
Okay.
I get back to it. And it's
Now you
not
don't have a
lot.
continuous circuit here, you know.
No, I know that. I was going from,
Oh, I see.
I was,
Doing the current, yeah. Okay.
right.
Very good. You gotta go to
Here.
milliamps. That's ohms. Gotta go to, let's see, right over here. Okay, let's try that.
Oh, okay, I was trying to verify that.
Okay. First, let's try that. Okay. Don't see any current there. Okay. Oh,
Everything's
and your
connected.
battery looks like it's a problem here. Yeah, you got a battery issue. All right, so you're not going to get the current. So, yeah. Now, if you want to do resistance, then you're going to have to go to there. 20K. There you go. Actually, 2K. There you go. Now you should be able to get them.
See, that's what I was
Oh,
running
no.
into.
No. Here to there.
Oh.
Okay, that's the resistance.
Gotcha.
1, 2, 3. Otherwise, you're measuring across the battery again.
Gotcha.
Okay.
Okay.
Very good. How we doing, Casey? Looking good.
I think I'm on the right track.
Okay, good. I like this. This is good.
Okay, so I added these up and this is what I came up with.
And how did it look? Yeah, 8.13, 8.39. So I imagine if you actually look at it under load, it actually is that. What, are you on voltage?
Yes,
Okay, so see if we look at it under, see,
8.12,
okay.
the change.
Okay, so here we run into something, so everybody stop for a minute. We ran into something here. He measured his voltage on his battery, but he did it open circuit. Then he put it in the load, and what happened to the voltage?
Lowered.
It lowered. And he proved that because he goes, hey, it's 8.13, and I measured 8.39.
Same thing happened to me.
But when he put it in the circuit, it's 8.12. That's close enough. Okay? So remember, there's an open circuit and there's a closed circuit. When it's open, the battery is always going to be this, and it's going to draw down to this. Okay? So don't get confused on that. Okay? Good. Go to work.
So parallel, you just go.
All right, parallel, just all three of them in parallel. So that'll be the next one. I'll draw it right here. Okay? And like this. R1, R2, and R3. Okay? Just like that.
I got a question.
Yes.
So are R3 and R1 in series with each other?
On that combination,
Yeah.
I don't care which
I mean,
one.
just the way it's set up right now. Are they in line or they're in series?
Okay, so how do we solve this?
I would split it into two different groups, but I'm just asking if R1 and R3 are in series together. Or is it just R1?
But you're asking the wrong question. Think about your circuit.
I thought about it.
Okay. You're going to solve this much of it right here, right?
Yeah.
And you're going to call this RT when you solve it, right?
Alrighty, yep.
RT?
Yep.
So your question to me should be, does that mean that R3 and RT are in series? The equivalent circuit is going to look like this. RT and R3, and then you'll solve that circuit. That's why you got to show your equivalent circuit. All right, you guys haven't got that far yet, so disregard for now until you get there. Does that make sense? Okay. Your question had to be RT and R3, and then it makes sense. We having fun yet? Once you have fun in this class. If you don't have fun in this class, then we got to change class.
Do I have to jumper or something here?
To get it to work?
Or do I just, I'm not familiar.
So which one are you doing now? Oh, parallel.
Just
You know
go
what
straight down the line or
You can
what?
just go like this. Well, actually, you could just go. Let's see. Well, what we're going to have to do is here's what you really should be doing. Which one's plus and which one? Okay, you got the wrong one here. So we're going to put the plus battery here. Okay. We're going to put the negative battery here. Then we're just going to put these across like this.
Across the channel?
And then we'll put this next one right across like this. Okay. Here we go. Put it right here. And then the next one right across there. And then we'll use jumpers.
2 milliamps? Yeah.
Okay.
Do you have to go higher then? I've tried all of them.
Okay, so are you guys having trouble with the current?
Yeah.
Yeah. That's what I figured. They're not, none of them working. It's really hard to see that little of a current
But
on
the
these
green
meters.
show it.
Do they? Okay, grab that and let's do it. Okay, so here's what you're gonna do. Then you're just gonna
I need to put on the right setting.
do this.
And Gordon, I gotta take off. Can can I finish this? How do you like finish this?
Whatever you got done, I'm just gonna grade this one the way, whatever you got done, okay? So just turn it in, you know what your assignment is, see, there you
Now, help
go,
me understand why we just did that.
because they're all in parallel.
Right.
Here's negative through the resistors, all of them, and then to the positive. Actually, oops. This, right here. Sorry, negative through all the resistors to the positive, see? Positive and battery. So it's a complete circuit now. They're all in parallel.
So now I take measurements off the battery while it's in the circuit.
Right. And in parallel, what's the, in your notes, one more thing, okay? And then we'll be done. What's the other rule? The current rule's the same, the current's the same in the circuit that's series. In a parallel circuit, what do we know about voltages?
Voltage is the same.
They're all the same. Write that in your notes. Go back to your notes and write that in. Both of those laws are important. We didn't get to Kirchhoff's law, but we will. But those two laws are the most important laws that we'll use probably all semester. So the second law is, in a parallel circuit, all the voltages are the same. Oh, get that wrong. In a parallel circuit, all the voltages are the same. Okay? In a parallel circuit, all the voltages are the same. And you got that, Mark. You no problem with that one.
No,
In your
I know.
notes. Put it in your notes.
Voltages in a parallel circuit
Are all the same. So just go ahead and drop that in your notes there, Mark. And then you're out of here.
And current is in a series.
Current is the same in a series circuit. In a parallel circuit, the voltages are all the same. Does a green one work for
Yeah.
current? Okay.
Yeah,
It's the difference between the 2 meters, and current is always hard. I always calculate my currents. Okay?
This one's American made.
So if you can't, yeah, it is American made. That's probably the difference.
So this dropped down to 7.3 volts.
Great. So it's loaded it right down. Okay? Do the equivalent resistance, and you'll see why. It's going to be pretty small. What do we know about resistances? In parallel, the resistance, the total resistance is smaller than the smallest resistor. And in series, total resistance is larger than the largest resistor. Okay? That's how you check it out. Okay?
I just put 0.016. Okay.
And that's correct. 0.016 is right on the money. So
16 milliamps?
yeah, 16 milliamps because you move it 3 places.
Okay.
All right, see you Thursday.
Yep, see ya.
Yeah, 16 milliamps. That's 1,000, and you move it 3 places. If you move it back 3 places, it's 0.016. Okay?
Okay.
And you're 0.015 calculated, so you're right on the money. Okay, so you gotta allow for a little bit of leeway on the meters. 0.001 is close enough for me. Okay. And if you just show calculated currents on the physical, I'm okay with that. Okay, I can live with that. Okay. Currents I don't get too excited about. I mean, you got to get them right, but if you're going to try and measure it, and you put on there, I cannot measure this with my meter, and it's a current, that's good enough for me, because those red meters are a little flaky. Okay. What you doing? You trying to get voltage, or what are you trying to do?
Resistance.
Oh, but you can't do it while it's in the circuit. You got to break the circuit because you cannot do resistance while you got voltage on the circuit. So guys, there's good lesson. If you're going to do resistance, make sure you take the voltage off the circuit. Lift a lead.
Why is this jumping around so much?
Okay.
That can't be right.
You gotta hold it tight. See, 52.7. All right, can it? We'll add them up and see. How do you add them up in parallel? What's the formula? Can't remember your name. Steve. Steve, what's the formula? Give it to me.
R times R1 times R2 over R1 plus R2.
R1 plus
R2.
R2. Okay, and that's RT, right?
Yeah.
But that's only for 2 resistors, and you have to do it again, right?
Right, but I have to figure, put 2 of them in series, right?
You got it. No, this is the combination circuit. You're doing the parallel circuit. Over here. Sorry. Let me put it over here. RT equals R1 times R2 over R1 plus R2. Okay? So this is RT right here. All right, you have to apply that twice, don't you? Because you're going to do this one first, and you're going to show me an equivalent circuit that looks like this, RT and R3, right? Then you apply this formula again, which makes it RT1 equals RT plus, times R3 over RT plus R3. Does that make sense, Steve? RT, because see, you made this into RT right here. You have to do it again. The only other way to do it, Steve, is to do R1, 1 over R1, 1 over R, or RT, 1 over R1, 1 over R2, plus 1 over R3. Then you can do all of them at once. And it doesn't matter. Whichever one you're comfortable with, I'm okay with. Just show your work so I know which one you did. Okay? And in the field, you'll be really tired and you'll only remember one. So you just have to do it on paper. Always take paper and pencil with you.
Doesn't make sense.
What's that?
Different resistors.
They're in parallel. So it's showing you the total resistance for all 3 of them.
Gotcha.
Figure it out. Do the calculations over there, Steve. Do these right here. Do the equivalent. And the RT1, this right here, this should be that resistance that you see that you're looking across all 3 of them. Okay? I bet you're going to be 50, what is it, 57.1? 52.7. I'll bet you it's real close to that when you calculate it out. Okay? How you guys doing?
I'm not getting
Okay, so you trying to do current?
any. No,
Yeah, you're-
resistance.
No, no.
Oh,
You can't-
there it goes.
That isn't how you do resistance.
When they're all in.
Just do it across the resistors. Make sure that there's no power across it. There. Oh, look at that. 52.6.
Okay.
See? You got to take the power off and go across the resistors. How we doing?
I think I'm on the right track.
Okay. So guys, we've got about 15 minutes left. I think what I want to do is finish this lab on Thursday. So I'm going to let you keep it. Okay? And then Thursday, you can keep your circuits, put them in your tote and everything so you're ready to go. And then what we'll do is we'll have a little lecture and then we'll finish your lab. And then we'll do another lab. If we have time, we'll do another lab, okay? So we'll give you another 5 minutes and then we'll go ahead and clean up. I have an assignment for you, so in 5 minutes when we get cleaned up, I'll give you your assignment out of the book.
So is it 1 over this? This is the total.
Okay, so you're going to do this one?
Mm-hmm.
You have to make all of these the same denominator
What?
so you can add them up, okay? Oh, I see what you did. You just divide it and then add them up and get
Right.
this.
Right.
Okay, now you have to make it back into a fraction, or I guess you can do it that way.
Is it 1 over 0.02?
That's right. It'd be 1 over 0.02. I see what you're doing.
So 50.
Okay. It's not a real good way to do that because you're not.
That's
it's
what I
cl-
was familiar with, but
yeah.
I can change.
Well, when you do this, you introduce error into it because you're doing 3 places and there's more beyond that.
Sure.
Okay?
They rounded up. Is
yeah.
52.7 acceptable?
50 and 52.7 are at least 2.7 ohms off, which is that 10%? What's
No,
10,
it's a
10,
little
yeah, that
less.
is, okay, I would allow that because that's within 10%
You want us
tolerance.
to put this away?
Yeah, so that'll be good. So yeah, let's stop for now, but don't just put your circuit in your tote, put everything in your tote. The only thing you have to turn in is but you gotta tear the frizz off, okay? So just turn in your resistor thing, your color thing that you got. The little nomenclature thing or whatever it is, red, black, whatever.
And you wanted the questions from chapter 1 too?
I've got questions. No, I don't. I don't think I assigned anything out of the book,
Oh.
but I'm going to assign something for you for the next time. Okay. And you notice that we're not staying exactly with the book, mainly because if I did, then it would be so much duplication. You'd be bored the first couple of weeks, and we wouldn't get everything done. So what I do is add more interesting stuff onto the end. Okay. I want you guys to have fun. Okay. All right, now there. Make sure you put your names on your papers.
I give you all the facts and edges?
Yeah, Mark forgot to take those frizz off. Okay. Ugh, that Mark, you got to watch him all the time. All right, so here's your assignment. You got a chance here. Page 50, 4-8 questions. Not many of them. Page 50, 4-8 questions. Page 50, the 4-8 questions. There's 3 of them. Okay? There's a lot of calculation there, but there's 3 of them. Okay? And page 51, self-test. It's all straightforward stuff. Okay? You know what I'm going to do? I just noticed, well, go ahead and work with question number 4. We haven't really talked about that surface mount. Go ahead and work with question number 4, see how you do. And if it doesn't look
On
like...
the chip resistor?
Yeah, on the chip resistor under self-test.
Self-test.
I just
Okay.
noticed that. And that's, we really didn't talk about those. So if you can answer it, great. If you don't answer it right, I'm probably going to just throw that one out. Okay. Everybody got your color codes into me? Let's see,
Yep.
Josh, right?
I found it.
Yeah.
Wrote it down,
Sean.
Sean.
Sean with a C.
Dick used to call him Senior.
Him so close. Josh was so close. Yeah, hey you.
Is there a scene here?
All right, so Sean, Sean, I don't have your color code, so I think we can turn this